Okay, let's talk about error intervals. So error intervals kind of like upper and lower bounds. Y is rounded to 1 decimal place. The result is 5.2. Write down the error interval. Okay, so something has already been rounded and it becomes 5.2. So let's write 5.2 here. Now I've developed a little diagram here to help us out. 1 decimal place. What is the 1 decimal place number above 5.2? Well, that's going to be 5.3. And what is the 1 decimal place number below 5.2? That's going to be 5.1. Now we're going to find the numbers in between these, there and there. So that one's going to be 5.15. That's going to be 5.25 below those two and below those two. Between, rather. Those are basically our answers. It's just about how we write it now. So the error interval is written like this. 5.15 is less than or equal to y, which is less than 5.25. And this is really important. So y can be any value between these two numbers. It can be 5.15 because we know when it comes to rounding numbers, if that number is a 5, it pushes this up to the 2, 5.2, which is what we want. But this is not included in the 5.25. So y can be less than 5.25, but it's not going to be 5.25 because of course that would round up to 5.3. So these symbols here are really important. So these are the upper and lower bounds, of course, but when it comes to error intervals, we need to use these symbols. Okay, let's do another example of error intervals. So here, this time it's rounded to 2 decimal places, and we get 1.51. So what is the 2 decimal place number above and below 1.51? Well, that's going to be 1.52 and 1.50. Now we find the midpoints there and there. That's going to be 1.505 and 1.515. Now, these numbers are always going to end in a 5, like 99.9% of the time. So if your answer doesn't end in a 5, you fucked up. So now let's remember the format of our error interval answer. 1.505 is less than or equal to x, which is less than 1.515. So remember, keep the equal to there, but not there.